Okay guys, in this video we're going to be solving trigonometric equations, and before I get started I want to show you two methods I'm going to use, and you're going to choose, well, whichever one you would like to use. So here, if you know your graphs, you'll know that this is my sine graph, and if you've plot one of these before, you'll recognize it's a circular function, works in terms of period, a periodic function. So ideally you'll get sort of a circle happening. Now let's talk a little bit about the sine graph. I've got mine in terms of radians here, but I think I might just change that to degrees. So this is 90 degrees here, this is 180 degrees, that's 270, and this is 360 degrees. Okay, this is just generally for the purpose of people who are watching and about to do further maths GCSE. You'll most likely be working in degrees as opposed to radians, but it works in the same way. Anyway, so some key points to notice. So you can see the sine graph cuts the x-axis at 0 here, at 180, and at 360. And we can use it to find solutions to problems. So down here I've got a couple of problems, and I'm going to show you two ways in which we're going to do it, like I said. So first of all, root 2 over 2. So sine of some angle is equal to root 2 divided by 2. Now root 2 over 2 as a decimal is 0.7. So 0.7 we know is somewhere about there. 0.7 is, yeah? So so sine of some angle is going to give me 0.7. So what I'm going to do is, I'll average where my 0.7 is. I'll go across there, and then what I need to do is come and read off that value down here. So you can see I get two answers for this here. So I just need to find out what these two angles are. Well, use your calculator then, and say, make sure your calculator is in degrees because we're working in degrees, and say that theta is going to be sine inverse of root 2 over 2. And once you've done that, that will give you the first angle. So we'll just do sine inverse of root 2 over 2, and that should be 45 degrees. Okay, good. So now I know that this angle here is 45 degrees. Now, what I also know is that this distance is 45 degrees there. I can now reflect this angle on the other side over here. So reflect that 45 degrees over there. So if I want to know what this answer is, you can clearly see it will be 180 take away 45 degrees, which I'll actually write this down. So my second answer is 180 minus 45 degrees. So my two answers are 45 degrees and 135 degrees. Okay, I neglected to mention before I started the problem that usually when you see them you'll be given a range in which to look for your answer. My range here is all answers for theta between 0 and 360. So I'm alright with these two answers. Sometimes they might restrict you and they might say between 0 and 180, or they might say 180 to 360. So if they had said 180 to 360, I will completely ignore this 45 and only take this answer because it doesn't fall in the range. Okay, so that's one way of doing it, using the graph to then sort your answer out. Another way, this is a way I quite like using it, is using the cast circle. And I'll tell you what this is then. So we call it the cast circle. And what it basically means is, this is all trig ratios will be positive here. This is only sine will be positive. This is only tan positive, and this is only cosine positive. and the cast circle goes in an anti-clockwise direction, so it goes in this direction here, where this will be 0, this will be 90, this will be 180, this will be 270, and then we're back to 360 there. Now, it's going in an anti-clockwise direction, like I said. This is my first quadrant. This is all angles between 0 and 90 degrees. And what I'm saying to you here is all sine, cosine, and tan of any angle between 0 and 90 will always give a positive answer. But between 90 and 180, only sine of an angle give a positive answer. Between 180 and 270, only tan of an angle gives a positive answer. And last of all, between 270 and 360, only cosine of an angle gives a positive answer there. Now, what I want to also do is show you what actually happens when we find an angle. So let's just say I was doing this exact same problem just now. I will find sine inverse of root 2 over 2. I'll get my 45 degrees. Now I already know that the answers I'm looking for theta gives a positive value of sine, because this is a positive value here. So I already know that my first answer is in my first quadrant. I can then put that 45 degrees in here, and I know that's my first answer. My second answer is in this quadrant, because this is another place where I'll find an answer that gives me, will find an angle that gives me a positive answer. So what I can do is reflect this angle over here. So reflect that 45 degrees here. And so if I want to know what this angle is from 0 all the way to this point, it will have to be 180, take away that 45 degrees. And that's exactly what we did down here. Okay, so let's make a little bit of notes just to be on the safe side about the quadrants then. And I'm going to blow this up a little bit, and we'll make the notes here. If I want an answer in the second quadrant, it will be 180 degrees, take away whatever your theta is. So whatever this first quadrant angle was, 180, take away that angle gives you the answer in the second quadrant. If I want an answer in the third quadrant, obviously I will reflect my angle down here. So let me draw that in. I'll reflect that angle down here. That's going to be my 45 degrees. Let's just say it was 45. I'm just using it hypothetically. Then the angle I need is all the way around here, past 180, and then 45 degree more. So if you're guessing right, then you will know that the angle down here will be 180 plus that angle, whatever that angle is. And just the same way, I can reflect the angle over here for the fourth quadrant. So let's just use the 45 again, and you can see the angle that I need would be all the way around here, and it stops there. So that will be 360, take away whatever that angle was. So there we have it. That's how we will find out what goes on in different quadrants. So remember, I hope you've written this down. Second quadrant, 180, take away the angle. Third quadrant, 180 plus that angle. And fourth quadrant, 360, take away the angle. Okay, I'll put my 0 there for my 360. Okay, lovely. Now let's look at a different problem, and we'll use both methods again to work them out. So here I have got sine of some angle is minus a quarter. Let's forget, actually no, let's go with it. Let's go with it. Minus a quarter. Well, this is where the negative part of my y-axis is. minus a quarter, that will be between a half, isn't it? Between 0.5. So between minus 0.5 actually. So minus a quarter is along here. So what I'll do is I'll draw that in. Draw it in a different color. Draw it in with green. So I'm going to go across here for minus a quarter. And then as soon as I hit that, that's where my minus a quarter is. So the two angles I'm looking for are here and there. Okay, here and here, because right where I cut the graph, I just take that up. So those are the two angles I'm looking for. Well, this angle is just past the 180. So what I want to do, I want to know, actually let's blow this up and discuss this a bit further. What I want to know is simply this. What is this distance from here to here? And I don't know that distance at all. And I need to find that out. So let's find it out this way first. What I like doing is, even though I'm looking for an angle that gives a negative answer, I like finding it in the positive in the first quadrant first. So what I'm going to do is I'm going to say that theta is sine inverse of a quarter. Notice I've ignored the negative for now, and the reason why I'm doing that is because this function is symmetrical. So if I find it here, then I know it's going to be the same distance there. So I'm going to find it in the first quadrant first. So I'm going to go to my calculator and I'll do sine inverse of a quarter. Again, please make sure your calculator is in degrees because we're working in degrees on this one. And this one works out to be 14.5 degrees. Okay, so now that I know that that's 14.5 degrees, that's not my answer, mind you. Now that I know that that's 14.5 degrees, then I know that this distance between here is 14.5 degrees, and this distance between there is 14.5 degrees. So to get what this angle is here, I will add 14.5 to 180, and I will take away 14.5 from 360. Okay, so let's go and do that real quick. So my answers that I'm actually looking for, theta, is 180 plus 14.5 and 360 take away 14.5. Okay. Alright, so that gives us an answer of 194.5 degrees and 345.5 degrees. Okay, so that took a lot of explaining, but at least I hope you got the idea. Now, if I was using my cast circle for that, I would have done the exact same thing. I would have found my 14.5 degrees over here, but I only want angles that gives me a negative answer. I don't want a positive answer. So I would have used my 14.5 and then I'd gone to my cast circle and said, well, okay, sine is positive here and in the second quadrant. But I don't want a positive answer, I want a negative answer. So I have to go and look in quadrants where sine does not belong, where sine will be negative. This quadrant, only tan is positive. So this is one of my quadrants I'm going to look at. In this quadrant, only cos is positive. So this is the other answer I will look at. So just the same way, if I'd reflected that 14.5 in this quadrant, then it would have given me 180 plus 14.5, which is exactly what we did here. And 360 take away 14.5, which is exactly what we did here. Okay, so that's why that's how we would work that out, because we want where sine is negative, we want a negative answer for our angles. Okay, so that took us a good deal of 15 minutes just to explain that. Let's move on and then see if we can get a little bit quicker. Okay, so here we have a couple of new problems, and now we're going to deal with cos. And as you can see, I've got my cos graph. Now, I might as well quickly draw in my cast circle, just because I know I'm going to be using it really soon. Well, I'm going to do both methods again. Cos graph is slightly different from sine. So here we have our 90, here we have our 180, 270, and 360. Okay, now let's go to the problem. This one says, actually I think just for fun I'm gonna make this one negative now. Okay, so this one says cos of some angle gives a negative answer. The negative answer is a half. Okay, here is my negative half here. That's my negative half. So when I go across, I will notice that the answers I'm looking for are there. Keep going across there and there. So that's where my negative half is, okay? So this is where I'm looking for my answer, here and here. Well, as you can see, again, what I want to know is, let's blow this up a little bit. What I want to know is what is this distance from there to there and this distance from there to there. And what I will do first is to find what it is for positive a half. So positive half is there. So if I find this distance, this is going to make life rather easy for me. So if I find that, if I know what this angle here is, it's going to make my life really nice. So let's go and work that out and see what happens. So as you can see, I will need to start with theta is equal to cos inverse of positive a half first. I like finding it and positive first. Okay, so when you go through your cos inverse of a half, you'll find out that that's going to be 60 degrees. Okay, so that's going to be 60 degrees. Now that I know that, because my answer is over here, where cos is negative, because remember I want the negative answer, it's gone past 90, but now you've got to think about this slightly differently. And how you need to think about this again is from 180. I probably should have made that clear rather than do my angles the way I did it, which is one of the reasons why I like the circle, because you wouldn't make this mistake. When I mark this out, this 60 degrees is the distance from here to here. Now if I reflect it over, it means that the distance from there to there is 30 degrees. Okay, so this is going to be 30, which means that this little piece here is 30 degrees as well, which means that this little piece is 30 degrees. How I know that? Well, this is 90 and up to here is 60. So I have two choices now here. I can do 180 take away 60 and it will give me that answer, or I can do 90 plus 30, whichever works for you. But I like sticking to the circle. It feels a little bit safer. You'd hardly make, I mean, I know that this will be a misconception someone will have. So I'm mentioning it now so you can have a think about it and see it. Yeah, so this is going to be 60 degrees there. Okay, good. Right, now that we know that, you choose whichever way you want to go for it. Okay, let's go back through here now. So I know that that's 60 degrees. I will go for 180. Take away 60 is what I will go for. Okay, so my answers that I'm looking for is 180 minus 60 degrees and 180 plus 60 degrees. Do you see where I'm pointing? Plus 60 degrees there. So 180 plus 60 degrees. All right, so this gives us 120 degrees and 240 degrees. Okay. Now, if I was working from my cast circle, so my cast circle over here, what I would have done is I would have had my 60 degrees, but bearing in mind I want a negative answer. Cos is positive in this quadrant, it's not negative, so the answers I'm looking for are here and here, because here only sine is positive and here only tan is positive. So once I reflect it in this quadrant, remember from what we mentioned a few minutes ago that in the second quadrant it will be 180 take away 60, which is exactly what we did here. And in this quadrant, it will be 180 plus 60, which is exactly what we did here. Okay. All right, let's move on to the next question real quick. So again, I will go for theta is cos inverse of 0.84. Now, let's go to our graph first, because I keep mentioning the graph because there would be somebody who likes the graph better than the circle. I personally favor the circle, but somebody else might not. Okay, so 0.84 should be somewhere about there. So if I draw that in, so you're going to notice one of my answers are here, and the other answer is there. Now, for the answer that is here, once I got that, it will be, well, let's find it out. So it works out to be 32 degrees. So let me write that in. So this is going to be 32.9 degrees there, 32.9. Okay, now that's my first answer. I'm happy with that because that is the correct answer. Cos is positive. This is a positive answer. So we're happy with that. That's the first answer. But what would be this answer here? Okay, if this distance from here to here is 32, then we need to work it back the same distance reflected from here at 360. So it will be, so that's my first answer. I'm happy with this answer. So my next answer will be 360 take away that 32.9 degrees. So my two answers are 32.9 and 327.1 degrees. Okay, and those are my two answers for that. All right, so I hope you've had quite a lot of practice on this now. I've just got one more to show you on tan, and then we'll stop. Okay, so this is our tan graph, and the tan graph has got an asymptote here. Asymptote obviously means that the tan graph will not touch this line, so it'll go all the way to infinity, but it wouldn't touch this line. It'll go down to a negative infinity, wouldn't touch that line there. So so this is going to be 180, 270 and 360. Now with your sine and cos graphs, you will notice that they only went up to 1. So as you had that periodic curve, it went up to 1 and came down to -1. But the tan graph can go all the way to infinity, so that's okay. All right. Now, let's just say we're looking for, actually, why don't we look at a problem? Actually, before I do that, let me just draw in my cast circle. Okay, and right, let's look at a problem. So here I've got a problem where I need to find tan of theta is 0.75. Okay, so let's go through the motion. Theta is tan inverse of 0.75. It's a positive value for tan. And I'm just going to pop over now to my graph. 0.75 is somewhere about there, between halfway between 0.5 and 1. So I know that my first answer and my second answers are there. So that's my first one. This is my second one. Okay, so that's pretty straightforward then. We go back over here and you can punch that in your calculator. So we find out that this is going to be 36 36.9 degrees is what we're going to get there for that one. And once we have that 36.9, you're going to notice that tan of that same angle, so that distance here, probably should make this a little bit bigger so I can explain it. This is 36.9, which means that when we reflect it over here as well, that's also going to be 36.9. So it'll be 180 plus that 36.9 degrees. So I'll pop back over here and we'll say that's going to be 180 plus 36.9. Alright, so our final two answers then will be theta is equal to 36.9 and 116.9 degrees there. Oh, I do beg your pardon. 216 is what that should be. 216 there. Okay. All right, good. So, and that's pretty much that. Okay. Again, if I was using my cast circle, I would say, well, that tan of some angle gives me a positive result. Tan is positive, well, they're all positive in the first quadrant, and tan is also positive in the third quadrant. So in the first quadrant is where I would have had my 36.9, and in the third quadrant, as you remember, as we mentioned at the very beginning, this would have been 180 plus 36.9, which is exactly what we did there. Okay, it'd be a good idea for you to pause the video now and have a go at doing this one on your own, but I'm just going to go straight for it. Okay, so again, theta is tan inverse of square root of 3. Now you know by now why I would ignore the negative, okay? Because I want to find what it is in the first quadrant first. Okay, so tan inverse of root 3 is 60 degrees. So that's going to give me 60 degrees there. If you want, you can go and work it out here, but this time I'm just going to pretty much go from there. Square root of 3 should be further up there. Anyway, I will read them off there. Now, I want the negative version of the angle. I don't want the positive version of the angle. So if I was reflecting my square root of 3 down at the bottom here, square root of 3 is about 1.7, somewhere around there. So that should be somewhere all the way here. I'm sorry, I pointed there. Should be somewhere all the way down here. You're going to realize that that's my first answer. That's my second answer there. Okay. Like I said, I like finding it in the first quadrant. So I already know it's going to be 60 degrees. So my 1.7 should be somewhere there. That's going to be where my 60 degrees is. This distance from here to here is 60 degrees. So it will be the same distance reflected back here. So to get this answer, I will need to do 180 take away 60 degrees. So that's going to be 180 take away 60. But where else does that happen? It happens over here as well. And this distance is going to be my 60 degrees here. So for this one, 360, take away that 60 degrees. So I'll finish off by saying that the answers are 120 degrees and 300 degrees. Those are what the angles that theta is. So this is it basically, guys. Just the same way I could have done it here. Find tan inverse of 3, so that's root 3, that's 60, that's there, but I don't want it in the first quadrant. I want it where tan is negative, where the angle is negative. So tan is negative in the second and the fourth quadrant because only sine and cos are negative there. So in this quadrant, tan is negative, so you would have done 180 take away 60 and in this quadrant you would have done 360 take away 60. Okay guys, I know it's been a long video, but you know, we had to get the point across. I've used two methods here. When you do it for your exams, you can use any of the two methods. You can use the graph if you want, or use your cast circle. I personally find the circle a lot nicer to work with. It gets me there quicker. But you might favor the graph if you feel like it. Okay. Look out for a second video on it where I will do more complicated problems. These ones were just straightforward, but it can get a little bit more complicated, and I will do that at another time.